Hello everyone, welcome back to Materials Conceptual Study. In our ongoing heat treatment lecture series, we will explore the effect of alloying elements on carbide formation and solid solution strengthening of carbon steel. When alloying elements are added to carbon steel, they can either dissolve in the solution or form carbides. Elements that go into solid solution contribute to the solid solution strengthening, which enhances the toughness and mechanical properties of the steel. On the other hand, carbide forming elements contribute to the formation of carbides, which can provide additional hardness, wear resistance, and similar other properties. Some elements such as cobalt, nickel, copper, and zinc have a preference for dissolving into the solid solution phase when added to the carbon steel. On the other hand, elements like titanium, chromium, molybdenum, tantalum, tungsten, and niobium form carbides when added to carbon steel. There is one simple rule to remember this trend. If the elements lie right to the iron in the periodic table, then these elements prefer to dissolve into the solid solution rather than forming carbides and contribute to the solid solution strengthening. But if they left to the iron in the periodic table, then these elements combine with the carbon present in the carbon steel to form stable carbides and contribute to the hardness and wear resistance properties of the steel. Furthermore, if the steel has a relatively small amount of carbon and a high quantity of carbide forming elements, the carbon will combine with the alloying element to form carbides before all the carbide forming elements are consumed. As a result, excess carbide forming elements will remain in the solid solution phase of the steel because they have no more carbon to form stable carbides. However, at lower concentrations, these elements can still dissolve in the solid solution and contribute to the solid solution strengthening while forming only few carbides. Thank you all for joining me today. If you have any questions or would like to discuss any specific topics in more detail, please feel free to reach out in comment section below. Stay curious, keep learning and have a great day.